Hello, HLC students. Welcome to another week of Math at Home. Today is our 14th video, and we're gonna be dividing our lesson into three sections. We're gonna have our sixth graders learn about modeling and solving one step, one variable inequalities. Our seventh graders are gonna learn about linear relationships, and our eighth graders will learn about reflections. Let's get started. For our sixth graders, our objective is to write one variable, one step inequalities to represent problems. Let's say that I run 3 miles and I take more than 30 minutes. The question is, how much time did I at least spend on each mile? So now that we looked at the problem, we are going to be modeling in order to solve this inequality. So we know that I ran 3 miles and that I took at least 30 minutes to complete all of these running. Now, the only thing that I need to find is how much I ran per mile. So I'm gonna set up the inequality. I'm gonna put the three x's on one side. I'm gonna put the at least or higher than or equal to symbol. And now because I have on the other side 30, the only thing I have to do is I'm going to divide the 30 into the 3 miles. So of course, I'm going to do it one by one so you can see how this process is modeled. And once I do that, I realize that for each mile, I took at least 10 minutes to complete it. So my answer is going to be I took or he took at least 10 minutes per mile. The next problem says Maria purchased 6 tickets to go to the museum. She spent more than $132. How much did she spend for each ticket? So in order for us to start this inequality, we're going to start with the 6 tickets that she purchased, which we don't know yet how much she spent for each one. So I'm just going to represent that price with an X. And then the symbol for more than is going to be higher than, and then on the other side, the total amount spent, which was $132. So now we are just going to use inverse operations in order to solve our inequality. And that means that since the 6 and the variable x are multiplying, the inverse of that is going to be dividing. So I'm going to divide 6 so I can isolate my variable. And of course, if I divide 6 on the left, I'm going to divide by 6 on the right side. So that means that once I divide, 6 divided by 6 is going to be 1. So x has to be equal to 22. I'm sorry, it's going to be higher than 22. So that means that Maria spent more than $22 for each ticket. And now it's gonna be your turn. Let's read the following problem. It says, Ronaldo scored 2 goals per game in a tournament. If he scored less than 14 goals, how many games did he play? We have 3 different answers. Did he play more than 6 games? Did he play less than 7 games? Or did he play more than 7 games? You're going to have a couple of seconds to answer this question. This problem says that Juan's sister is 5 years older. That means that higher, or we can put the plus sign, than him. If his sister is at most, this is another keyword, and we are going to represent this at most with the lower than or equal to symbol, 17 years old, how old then is Juan? So this is going to be our question, and in order for us to solve this, I'm going to start with the age of Juan, which is the variable that we don't know, so we can represent it as J, and that's the variable that we don't know, plus the 5 years that his sister is older than him. And then I'm going to put the symbol at most, so it's going to be lower than or equal to, and then the total is 17. So now, in order for us to be able to solve the inequality, we're going to be using again inverse operations. Since this 5 on the left is adding, then we're going to be subtracting 5 on the left. And if we do that on the left, then we have to do the same on the right side. So that means that J is going to remain isolated on the left side, lower than 17 minus 5 is going to be 12. In other words, Juan's age has to be at most 12 years old.
And now the problem says a puppy grows 3 inches in 1 month if his current height is more than 15 inches. How tall was he? So basically, we are going to start by getting an variable, which is the x, and that represents the height that he was before uh, he grew the 3 inches. And now I just have to add the 3 units representing the 3 inches that he grew on that month. I know that this is going to be higher than 15 inches, which is his current height. And now I have to use inverse operations to be able to solve this inequality. So that means that I'm going to put 3 negatives on one side. And remember, if I do it on one side, I have to do it on the other. So I'm going to take out 3 units from each side. And that means that the height that he was before he grew was 12 inches. And now it's gonna be your turn, guys. The problem says Lugo made more than $500 last week. If his mom gave him $100, how much did he earn by himself? You're gonna have a couple of seconds, and you have these 3 options. You're gonna be lower than $400, more than $400, or more than $200. Let's get to work.
For our sixth graders, today we learn how to model one-step inequalities using algebra types. And also we learn how to solve one-step inequalities using inverse operations. So now we're ready to go to the 7th grade section. For our 7th graders, today we're going to learn how to represent linear relationships in different methods. Let's say that I buy a Netflix subscription and the cost is $15 a month plus $3 that I pay for each movie that I rent. The question is, how can you represent the relationship between the movies rented and the total monthly cost? In order for us to do this, we're going to start by exploring how to graph this relationship.
And in order for us to be able to draw a graph to find the relationship between the number of movies rented and the monthly cost of Netflix, we're going to be using first a table. So the X's represent the number of movies rented, and I know that if I don't rent any movie, I'm just gonna pay the monthly subscription, which is $15. So I'm gonna represent it in my graph as a point on the 0 and 15 coordinate, which is right there. Then if I rent only one movie, then that's gonna increase my monthly cost by $3. So that means that that's gonna be 18, and my new point is going to be drawn right here. And then I'm gonna do the same for uh, the scenario where I rent two movies. That's gonna bring the total to 21, and that's gonna be the new point. And if I keep going, I can see that if I have three movies, I'm gonna pay 24, and if I have four movies, I'm gonna pay $27. So now I can see that there is a clear linear relationship between these two situations, and then I can draw my line that represent that relationship. Why is important for me to draw the line? Because now I can actually predict what's gonna happen if, for example, if I buy five movies. So if I buy five movies, then I can see, because of my line, that I'm gonna pay a total of $30. And this is how we graph a linear relationship. In order for us to represent uh, the equation of the line, the um, the form it takes is this one that we have on our screen, which is y equals mx plus b. And in order for us to continue with the lesson, we need to know what each of these letters represent. So we start with the red letter, which is the y, and the y represents the dependent variable because it depends on what the x value is. Some words that you are going to find on the verbal description are going to be the word total, or it also represents a final balance. Okay, we go to the next letter, and that's going to be the letter M. And this M represents a rate of change. It means a unit rate or a slope, and is represented by words that describe something that repeats over time. So something like per, or each, or every. Then we have the letter X, which in this case represents the independent variable. And the last word, the last letter is going to be the letter B that represents the y-intercept. This y-intercept represents an initial fee or an initial balance or a constant or something that is not changing or does not repeat over time.
On this problem, we have the bike rental fees, and they are given on this table. The question says, which equation represents the relationship between the miles that you drive the bike and the total cost that the rent um, is going to be. So in order for us to be able to find the equation of the line, we just have to find the differences that are happening on the y side. In this case, this is going up by 0.5. At the same time, we are going to also find the differences on the x's, and as we can see, the x is going up by a whole one number. So my my equation for the unit rate, or the letter m in our equation, is going to be equal to the differences in the y divided by the differences on the x's. In other words, I'm going to divide 0.5, which is the difference that I just found, divided by 1, which is going to tell me that the unit rate is 0.5. And then I can find B by just looking at the y-intercept. In other words, what is the total y when x is equal to 0? So that means that in this case B will be equal to 3. So with those two numbers I can then write my linear equation, which is going to be y equals m, which we know is 0.5x, plus b, which now we know is equal to 3. And that is how you use a table to find the equation of the line.
And now it's gonna be your turn. Based on the table that you have on the left, you're gonna pick which equation correctly represents the relationship between the x values and the y values. You're gonna have a couple of seconds to find the correct answer.
In this problem, we're going to find the equation for the relationship between the games played and the total cost paid at an arcade. And we have this one representing the x's and the y's on this coordinate plane. So in order for us to find the equation of a line from a graph, the first step will be for us to start with a t-table, where one side is going to represent the x values and the other side is going to represent the y values. I'm going to start with this point right here, which the coordinate on the x's is 0 and on the y's is 5. Another point right here that I can find is the x1 and the y is going to be 9. I can find another one, and that's going to be 2 and 13. And actually I can find as many as I want, but I only need a minimum of 2 points in order for me to find the equation of the line. So over here now I'm gonna start my strategy where I see the differences on the y. This is going up by 4. I can see that this is going up by 4, while the x's are going up by 1. So now, using my equation for the unit rate, I can see that the differences on the y's is 4, differences on the x's is 1. That means that my unit rate is going to equal 4. And of course, b can be found easily on a graph because remember that b is the y-intercept. That means that is where the blue line touches the red y-axis. So that means that this point right here is going to be equal to b. So with those two numbers, I can write my linear relation, which is going to be y equals m, which now we know is 4x, plus b, we know now that is 5. And that is how you use a graph in order to find the equation of the line. The next problem is a verbal description, and we're going to use our keywords in order to find the equation of the line. It says a moving company charges a $50. That's going to be our first number. That is a flat fee, and we know from our previous lesson that a flat fee is going to be a constant, something that does not repeat. So that means that this one right here is going to be my y-intercept, or in my equation is going to be the letter b. The next number is $55, and that is what the moving company charges per hour. In other words, this is a repeatable because it does it is a variable that is gonna be depending on the amount of hours that the moving company takes to move the um, items. So that means that this is going to be the unit rate. And now that I found the M and B, I can construct my equation of the line that is going to be equal to y equals m. Now we know is 55x plus b, which we know is 50. And this is how you take the verbal description and use it to find the equation of a line.
And now is your turn. And the problem says Erin owns $375 worth of comic books. She spends $15 every week on new comic books. Based on this verbal description, you're going to pick the correct equation. You're going to have a couple of seconds.
For our seventh graders, today we'll learn how to represent a linear relationship in the form y equals mx plus b. We learn how to represent it with a graph, we learn how to represent it with a table, and we learn how to represent it with a verbal description. And now we're ready for our 8th grade section. For our 8th graders, today we're gonna be learning about the generalization of properties of reflections of two-dimensional shapes. In order for us to start this lesson, we're gonna explore the definition of a reflection. And this is a transformation of a two-dimensional shape that is flipped across a line. This line is called the line of reflection. Both pre-image and image are the same distance from this line, and it works as a mirror.
And now we're gonna try our reflection on a triangle. And the triangle is the MNO. And we're gonna do a reflection on the x-axis. So that means that the line, the x-axis, is gonna be our line of reflection. So remember, the only thing that we have to do is we're gonna make our vertex our points, and then we're just going to move the point, and we have to make sure that they are the same distance from the line of reflection. So in this case, the M is 3 units on top of the X. So now it's gonna be 3 units below the X. That's gonna be the new reflection for point M. I'm gonna reflect point N, and is still 3 units above the x-axis. So now it's gonna move to 3 units below the x-axis. And the O is only 1 unit on top of the x-axis, so it's gonna be just 1 unit below it. So now that we have our 3 points, the only thing we have to do is put the points together, and that's gonna be our new image, and this is gonna be the triangle reflected over the x-axis. And now that we saw how we did the reflection of this triangle, we can see some key properties of this transformation. The first one is that the length of the sides of the triangle remain the same. The corresponding angles are congruent. That means that they remain equal. And the last thing is that the orientation of the image changes. This is the transformation that changes the orientation of a two-dimensional shape. And now it's gonna be your turn. You have our yellow image, and you're gonna pick which of the three figures, 1, 2, or 3, is a reflection of the trapezoid A? You're going to have a couple of seconds to pick the correct answer.
Now we're going to reflect the following figure across the x-axis. And as I said, we are going to get every point and we're going to reflect it so we can then just unite the points and draw the same figure just on the other side. So we're going to start with point A. It's going to remain on that same line, -1 on the axis, but now it's going to go to the other side on the -3. So now it's going to be right here, and that is going to be my new point A. I'm going to start with point B as well. It's going to remain on that +2 on the axis, but now it's going to go to the -3. So now it's going to be right here, and this is going to be B on the new image. I'm going to go with C, which is going to remain on that line, but now it's going to go to positive and it's going to go to -2. So it's going to be right here. I'm going to go with the D, that is on the same line as the 2 on the X, but now it's going to go to -1 on the other side. And as you can see, when I'm reflecting across the x-axis, the only number that changes on the point is the y coordinate, and it's actually going to flip to its opposite side. So for point E, if the coordinate right here is -1 and +1, then the only thing that I'm gonna change is this number right here, making it into its new location, which is gonna be -1, -1. So that means that it's gonna be right here. And we can use this algebraic notation in order to make our life simpler. So we're just gonna connect this, and now we just made our new image, and now is completely reflected across the x-axis.
And now we are going to translate this triangle ABC across the y-axis, but we're going to do it only using algebraic notation. So let's start with the point A. I see that the point A's coordinates are -1 on the x's and -1 on the y's. We now know that because it's going to be translated over the y-axis, the only number that is going to change is the x coordinate. Instead of being -1, now it's going to be its opposite. That means that it's going to be +1, and now we can put the point on +1 on the x's and -1 on the y's. We're going to do the same thing with point B. Point B is -3 and -2, and the only number that changes is the x coordinate. So now it's going to be +3, and it's still going to remain -2 on the y's. And now the C is -1, -4, and the new point then is going to be +1 and -4. I put my points on the coordinates, and I put them together, and now I have my triangle reflected across the y-axis only using algebraic notation. And now it's gonna be your turn. You're gonna pick which figure is a reflection of figure A. You're gonna have a couple of seconds to pick the correct answer.
Today, for our 8th graders, we learn about the definition of reflections Specifically, we talked that when we do a reflection across the x-axis, the y-coordinate is gonna flip to its opposite side. And when we do a reflection over the y-axis, the x-coordinate is gonna flip to its opposite side. And this is the end of our lesson for today. Thank you so much for watching another week of Math at Home. Remember to go to HISD at Home for more resources. Follow me on Twitter and Instagram for you to be able to watch these videos at your own convenience. Have a nice week, and I'll see you on the next Math at Home. Bye.